It's the timer. All right, so do we match? Do we kind of match? How do I get the 1? Okay, did you add the 2 to get 36? Did you square root both sides? Okay, so you have x plus 5 equals 6 and negative 6, right?
Wait, can you solve it?
So the first one you add 2 over. So you have x plus 5 squared equals 36. Then you have to square root both sides. So now we have x plus 5 equals positive and negative 6. So x plus 5 equals 6. X plus 5 equals negative 6. Subtract 5 from both of them. 6 minus 5 gives me 1. Negative 6 minus 5 gives me negative 11. When you square root, you have 2 answers. The second one, you subtracted 4 first. So we have x minus 6 squared equals 20. And then we square root both sides. 20 is not a perfect square, but a perfect square lives in it, right? It's 4 and 5. This becomes x minus 6 equals positive negative 2 square root 5. And then when you add your 6 over, because of the radical, it just gets moved up front. Okay. What we're doing today is we're writing equations to look like this, so that way I can solve using square roots. Okay? It won't always be given to me this way. Sometimes we're going to have to use a process called completing the square. Okay? That's what today is. Today is completing the square. Okay? You were probably introduced to it in Algebra 1. Okay? So I'm going to remind you what that was, and then of course we're going to give it a nice Algebra 2 twist. Yes. According to the state of Florida, yes, we do. There is a trick, actually. Yeah. Yes. Okay. So my first example here says solve using square roots. Okay. I have x squared minus 16x plus 64 equals 100. Okay. Looking at my trinomial that I have, it's a special trinomial. Okay. If I asked you to factor this and said what multiplies to give you 64 but adds to give you negative 16, what would you tell me? Negative 8 and negative 8, right? It's the same number repeated. Yes? Negative 8 plus negative 8 is negative 16. Negative 8 times negative 8 is 64. So because it's the same factor multiplied to itself, that means it's the same factor squared. So I can write it as the factor x minus 8 squared. And then now I can use the square root. I can't use the square root unless I just have something squared left over. Okay, now I just have a parentheses squared. So now we're going to square root both sides. So I have x minus 8 is equal to 10. I also have x minus 8 is equal to negative 10. Because remember, that's positive and negative 10. Add 8 over here to give us 18. And then we're going to add 8 on this side to get negative 2. Good. So like each example we do, we're like going to slowly tiptoe backwards until we can fully complete the square. So our warm-up, it was already squared. We just did square roots. This time we had to create that something squared and then take square roots. My middle one, x squared plus 4x plus 4 equals 36. How can I factor or rewrite that perfect square trinomial into something? This will be the same as what? X plus 2. There you go. Yeah. Because 2 plus 2 is 4. 2 times 2 is 4. So it's x plus 2 and x plus 2. We're going to write it as x plus 2 squared. From here, we're going to square root both sides. What is the square root of x plus 2 squared? Just x plus 2. And what is the square root of 36? Positive and negative 6. So x plus 2 equals 6, and x plus 2 equals negative 6. All right, we're going to subtract 2 all the way. Right here, 6 minus 2 gives me 4. And on this side, 6 minus 2 equals negative 8. Okay, these are still quadratics, so we talked about it. They typically cross the x-axis 2 different times. So this is what we're finding. We're just doing it with the strategy or the method of completing the square. All right, I would like you to try the last one, please. X squared minus 22x plus 121 equals 81. Try that one. Did you get 2 and 20? Yes? We good? We feel good about it? All right, so what we are doing, if I give you a trinomial, okay, in some situations you will have to add something in to make this process be able to work. Okay, like my plus 64, my plus 4, my plus 121. Sometimes that won't be there for you. Okay, you're going to have to make it happen. Okay, and that process is called completing the square. Okay, so if it's not given to you and you have to make it happen, you have to bring in the perfect squared number, you have to complete the square. Okay, when you add something to an equation, when you add something in, remember you have to do it to the entire equation. Okay, you can't just do it to one side. You have to keep it balanced. Okay, we have to keep it balanced. So, looking right here. And some of you asked for a little trick. There is a little trick. Okay, we're going to take our b value. We're going to cut it in half. And we're going to square it. Okay, think about the ones we just did. What's 16 cut in half? What's 8 squared? 64. What's 4 cut in half? 2. What's 2 squared? 4. What's 22 cut in half? 11. What's 11 squared? 121. So see how that was the pattern for all the ones you just did? So you can continue that pattern to create it yourself. Okay? So if I need you to complete the square and then factor it, okay, x squared plus 14x, what's the missing square?
49.
49, good. Okay. Squared.
Do we have to put equal?
Squared. Okay. Now I have to factor this. So how does this going to factor? X plus 7 squared. Good. So again, we did 14 divided by 2, and we squared it. 14 divided by 2 is 7. 7 squared, bless you, is that 49. Okay. We will make sure it is. That's a good thing, though. Yes, we want our b to be even because it makes life nice. It's not impossible if it's odd. We just don't like it. We probably wouldn't choose complete the square. I would probably do factoring or quadratic formula. I would probably do something else.
So what's the final answer?
So we completed the square with adding the 49, and then we factored it doing the x plus 7 squared. That's all this wants you to do right now. Yeah, we don't have to go beyond that. So my next one, x squared minus 2x. What's the square that we're missing?
1.
I heard it. It's a 1. Good. Positive 1. Again, we took our b. We cut it in half. Negative 2 cut in half is negative 1. And then negative 1 squared is 1. And then how do I write this as a binomial squared? X minus 1. Good. So another cool little trick you might notice, when you cut it in half, that's the piece that goes in your parentheses each time. Okay? You tried the last one. x squared plus 8x. What's the perfect square that should be there? 16. And then how do I factor it? It becomes what? This is the x plus 4 squared. Good. Okay. So that's the complete the square process. Okay. Now we're going to do it with an equal sign. So now it's going to be an equation. So when I bring in my perfect square, you got to do it to both sides of my equal sign. We got to keep it balanced. Okay? So here we go. This is very algebra 1, what you did. You solve x squared minus 10x plus 7 equals 0 by completing the square. Okay? Is 7 a perfect square? No. And so even if it was, it's not the square that I need. What should be there? Careful. 25. Look for your B. Okay? So we know 7 shouldn't be there. So how am I going to get rid of the 7? I'm going to subtract it to the other side. Okay? When you subtract it, leave a hole. Okay? Because you have to bring in the square, and now it's an equation, so you're going to have to bring it into both sides of my equal sign. So what square did you say I needed? 25. Is anyone confused on where 25 came from?
Yes.
Okay. So what's half of negative 10?
5.
And what's 5 squared?
25.
There you go. That's where it came from. We're not done.
Is that a 45 minute?
What do you think it is?
Oh, man. 45?
Oh, dang it. Okay, so what is my parentheses squared going to be? Is it x plus 5 or x minus 5? X minus 5. See how it's a negative 10 in the middle? Yeah. So it's going to be a minus 5. So x minus 5 squared. And now it's equal to what on the other side? 18. So we have x minus 5 squared equals a positive 18 because negative 7 plus 25 equals 18. All right, now that we have this set up, now what are we going to do? Square root both sides and solve. Yes. So square root both sides. We're left with x minus 5 equals what? Okay, I heard 3 times the square root of 2. Where did that come from?
9.
There you go, because that's the square root of 9 times the square root of 2. Don't forget there's a plus minus in front of that 3. Okay? And my other side has just the x minus 5. We're almost there. We have one more thing that we have to do. Because the x is not by itself. So what am I going to have to do? Add 5. There we go. So when we add 5 over, we get x is equal to 5 plus and minus 3 square root 2. Like that. Okay. How come I can't make it 8 square root 2? Yeah, technically they're not like terms. Right? I can't do that. If it was 5 plus 3x, you wouldn't put it together. Right? So 5 plus 3 square root 2, 5 minus 3 square root 2, not like terms, you can't combine them. Yeah? You try. Yes. X squared plus 8x minus 5. You try that one. You try this one. I'm going to put the answer up here. When you are ready to look up, it will be there for you. All right, questions? We do okay? Yes. Why is it plus minus? Because you took a square root. There's always a plus minus when you do a square root. Yep. What's up? Because you had to subtract 4 to the other side. Because it was x plus 4 squared. So to move that 4 over, you had to subtract it. Okay, any other questions? Yes? What's up?
So, why can't you do square root 4 times square root 1? Can you do that?
Square root of 4 times the square root of 1? What are you talking about? So did you add 5? And then you added 16 to both sides? Gotcha. So you forgot to balance it. You forgot to under 16? Okay. Yeah, make sure you do it to both sides. Okay. Here we go. Let's go to the back. All right, now we have 3x squared plus 12x plus 15 equals 0. My a is no longer a 1. Oh, no. What is my a? It's a 3. All right, my a is a 3. What else do you see? Everything is divisible by 3, right? So my a is not 1, but for this problem, I can divide every single piece by 3. And now it's x squared plus 4x plus 5 equals 0. 3 divided by 3, 12 divided by 3, 15 divided by 3, 0 divided by 3. Okay? All of them. Okay? Which means the 3 is now just gone. We don't need it anymore. Okay? Because it got divided by each and every piece, I don't need the 3 anymore. And now it's very much like what we just did. Okay? We're going to subtract that 5 over. Leave a blank because we know we have to bring something in. What do we have to bring in for this problem? A 4. Good. Does anybody not know where that 4 just came from? That orange 4. Okay. How do I write this? X plus 2. Okay. Equals what? Negative 1.
X plus 2 equals 1.
Negative 1.
I thought you did.
So now we have to square root, right? Here's an algebra 2 twist. What is the square root of negative 1? I. So we have x plus 2 equals positive and negative I, technically. Because now when I subtract the 2 over, it will be negative 2 plus minus this I. So there's where my complex numbers come in. Because before in Algebra 1, you would have said, oh no, no real solution. You weren't wrong. There is no real solution because it's imaginary. So we didn't totally lie to you. We just didn't tell you what it really was. Nah. That's no fun. All right, you try the next one. You try the next one. You have negative 3x squared minus 18x minus 33 equals 0. And when you are ready to check, bless you. Here we go. Check with me. See how we're doing. Questions? You should have negative 3 plus or minus I times the square root of 2. Yeah? We okay? Yes? All right, we're going to level up each time. So tell me if you have questions or if we're lost.
Where did the I come from?
The I came from taking the square root of a negative number. So negative 2, we can split that up as the square root of negative 1 times the square root of 2. So the square root of negative 1 changes to that I. But square root of 2 just stays.
All right.
Yep. All right, here we go. Now we are why are we doing this? What's the point? Because in unit 2, we had to rewrite things in a vertex form, right? From standard form. And it wasn't fun. Okay? We did like opposite B over 2A, you got the value, you plugged it back in, you got the K, but then you still had to like find the A and all that stuff. You had to use points. Remember all that? It was so much fun. You loved it so much. Right? That was your quest. So guess what? We can do this instead. Okay? To change standard form into vertex form. Okay? So I know we struggled. We worked really hard because you had to, but now we kind of get to take a break. Okay? There is a different way to do it as long as you can complete the square. So if I have y equals x squared minus 12x plus 18, okay? And it wants you to write it into vertex form, okay? And then we're going to identify the vertex. So we're going to do the same process that we just did. The 18 is in the wrong spot, right? How are we going to move it out of my way? Subtract it. What's already over on the other side, though? A y. No, not anymore. Now it's a y. So when I subtract it, it's going to be y minus 18 equals x squared minus 12x. Yes. I would. I mean, you don't have to, but I would to make life easier. Okay. So when I bring in my perfect square, okay, we will still add it to both sides. That is still a thing. Okay, what perfect square are we bringing in? Where did 36 come from? Taking 12, cutting it in half. Good, and then squaring it. So negative 6 squared is 36. You still do it to both sides. If you're bringing in something new, you have to bring it into everything. All right, so my y, the side with the y, what is that now going to look like?
Y plus 18.
Y plus 18, because we can combine like terms right here. What does the right side look like now? X minus 6, good, squared. And if we want it into vertex form, all we gotta do is get y by itself. So now we're gonna move that 18 back over here, right? So now it's y equals x minus 6 squared minus 18. So we had to move the 18 so I could complete the square, and then we were allowed to bring it back. Okay? It's not always the same number. This one is just special because negative 18 plus 36 gave me positive 18. Pure coincidence? That's not going to happen every time. So we have vertex form. That's part of my answer. What's the vertex? Yes, you do. What is it? 6, negative 18. Okay? Inside opposites. When you pull that 6 out, it changes its sign because it was in parentheses. And negative 18 stays where it is. Can you try the next one? Yes. Try it. Just try it. Try it. I'm not asking you to be perfect. I'm just asking you to try. See how far you can get. Y equals x squared plus 6x plus 4 is what I want y'all to do. And I'm going to put the vertex up here. I'm not putting the equation, I'm just doing the vertex. So you can check with that when you're done. All right, we are going to start number 6. We'll probably get through the first half, and then we'll finish the second half of the warm-up when y'all come in here tomorrow. Okay. The height in feet of a baseball, t seconds after it is hit, can be modeled by the function y equals negative 16t squared plus 96t plus 3. Okay. It wants us to find the maximum height of the baseball, and we're going to do it with vertex form. Okay. To get it in vertex form, we're going to use complete the square. Now, this kind of ties into the ones we did at the very top of this page, right? My A is not a 1. It's a negative 16. Issue now is I cannot divide negative 16 out of 3, right? I can divide it out of 96, actually. That goes in nicely. But the 3 is messing it up. So what are we going to do with that 3? Let's subtract it out of the way. Okay, so we're going to move the 3 over by subtracting it. We still have negative 16t squared plus 96t. So now the right side has a greatest common factor of negative 16. We're not going to take the t's away. We're going to leave the t's alone. So if I divide negative 16 out of both of those pieces, I'm left with t squared minus 6t. Okay. At the very top of our page, the 3's just like disappeared, right? That was because I divided every single piece of my equation by 3. Here I didn't, because I can't divide the 3 by 16. So it's not gone. It is still part of our equation. We just factored it out of one side, but it's still present. It still has its weight on that side. Okay? We are going to add something to complete this square, which means we have to add the same thing to the other side with my y minus 3. Okay. So we have y minus 3 plus something equals negative 16 times t squared minus 6t plus something. So what is the perfect square that we have to bring in? A 9. Good. Where did 9 come from? The 6t. Good. Half of negative 6 is negative 3. Negative 3 squared is 9. Okay? Now I want you to watch something. Watch. Oh, maybe. We'll see if the tablet decides to unfreeze. You're going to watch something. Wait for it. Hold on, it's frozen. Hold on. Okay. No, it's not 4. It's actually... Okay. Okay. Because you times it by what? The negative 16. Okay? So this is what's different about this problem. I didn't just bring 9 into the equation. I essentially brought in negative 144 to both sides because that 9 is being multiplied by negative 16. Okay, so because the 16 did not get divided by everything, it's still here, we still have to use it. Do not ask me questions about this later.
Yeah, I got it.
Okay. So my left side is going to be y minus 147 equals negative 16. This is now x minus 3 squared. I don't know, because I like x better than t. Sorry, thank you. And then we're going to add 147 to the other side to get negative 16 t minus 3 squared plus 147. So this is definitely the Algebra 2 style of completing the square when there's an a value that's not 1 that you can't factor out completely. Okay. So what is the vertex of this baseball? 3 and 147. Now, what was the question, though? What's my maximum height? So what is the maximum height? 147 feet. Good. Max height is 147 feet. They didn't ask me this, but I'm going to ask you this. How long did it take for it to reach its maximum height?
3 seconds.
Woohoo! Good job. Yes, 3 seconds. Okay. So what we're going to do tomorrow is we're going to figure out how long it took the ball to hit the ground. So that means that my y value is going to be what? 0. So we're going to make our equation equal to 0. All right. Good job.